Welcome to Radio Geek Garage, friends. Today, we're diving into the simplest Collinear antenna design, the Franklin antenna, named after Charles Franklin. He patented this design in 1924. In its basic form, the antenna consists of half-wavelength in phase segments and quarter-wavelength stubs extending perpendicularly. These quarter-wavelength stubs absorb half-wavelength currents flowing in opposite directions. To prevent unwanted capacitive coupling, the conductors in the stubs need to be spaced apart at a specific distance. Originally, the Franklin antenna was made from a single piece of wire, so it required gamma matching for cable connection. In simple terms, a point was found in the stub where the impedance matched the cable impedance. Without a matching stub, the antenna's impedance is around 300 ohms, while at the stub's end, it drops to a minimum. By adjusting the connection point, you can match this antenna with almost any cable. Later variations of the Franklin antenna introduced additional matching techniques. You can connect directly to the current maximum point at the stub break, use a balanced feed line, or shorten the initial antenna sections to a quarter wavelength. This modification results in a more modern collinear antenna design. However, in this case, the antenna must have a counterpoise or be fully symmetrical. The end half-wavelength segments should be shortened by about 10% relative to the calculated half-wavelength. This helps compensate for the capacitive component of the input impedance. However, even if you skip this step, the antenna will still work, just with slightly reduced efficiency. In practice, a typical Franklin antenna with 3 stubs has a gain of approximately 3.2 dB. This gain is expected given the number of in-phase segments. A 5-element Franklin antenna increases the gain to around 5.4 dB. The Franklin antenna is straightforward and easy to understand. It's designed based on wavelength, and the placement of current maxima and minima is intuitive. Let's calculate a 3-element Franklin antenna for 2412 MHz, which corresponds to Wi-Fi channel 1. The wavelength at this frequency is 124 mm. For a wire diameter of 3 mm, we'll apply a shortening factor of 5%. This results in an effective wavelength of 118 mm, meaning each half-wavelength segment is 59 mm. The quarter-wavelength stubs are about 29.5 mm long, and the end segments should be 53 mm. The spacing between stub conductors should be at least 3 mm. The best feeder connection point is closer to the end of the stub. Since most coaxial cables have an impedance of 50 ohms, and a 3-element Franklin antenna has an impedance of 300 ohms, this creates a 61 mismatch. To minimize this mismatch, the connection point should be positioned near the end of the stub. Interestingly, the stubs can be bent into a circular shape without negatively affecting performance. This trick can be useful when installing a Franklin antenna inside a tubular enclosure. The same proportional design applies to antennas with more segments. As you add more segments, the gain increases and the radiation pattern becomes flatter with maximum gain along the horizontal plane. If you found this video helpful, support the channel by leaving a comment, hitting the like button, and sharing it with others. Don't forget to check out more videos on the channel, subscribe, and explore the links in the description. Thanks for watching. Good luck.